In this lesson, we will be solving compound inequalities. At the end of the lesson, we will be able to solve compound inequalities containing the word and or, and graph their solution. Talking about the word compound. So remember, compound means to add it together, or there's two things. So like a compound sentence or a compound fracture. Okay, two things going on at the same time. So, talk about these. A hexagon has 6 sides, or a octagon has 7. A hexagon has 6, or an octagon has 7. Well, a hexagon does have 6, an octagon does not have 7, but since it's an or statement, it's true. An octagon has 8 sides, and a pentagon has 6. Well, octagon does have 8, but a pentagon doesn't have 6, and it says and, so that means they both have to be true. A pentagon has 5 sides, and a hexagon has 6. Both of those are true. It's an and statement, so it's true. 5 is less than 4, no. Or 8 is less than 6, also no. 4 is greater than 0, yes. And -4 is less than 0, also yes. So a compound inequality means that we take the two inequalities and we consider them together. And there are two types, a union and an intersection. An and compound means that they're both true. This is called an intersection because the two inequalities overlap, and the symbol kind of looks like an upside down U. So what this inequality says, it says x is less 3 is less than x, which is less than 5. So that means that x is greater than 3 because 3 is less than x, and it's less than 5. So x is between 3 and 5. When you have the x in the middle, that means it's an and statement, and both inequalities need to be true. An or compound means one or the other is true. So it's a union, and it means either one of them, and the symbol looks like a U. When it's an or compound, the word or is always between it. Okay, so when it says 3 is less than x, that's the same as x is greater than 3. And then or x is less than 5. So one or the other has to be true. All right, let's do some examples here. This one is an and statement because the variable is between the inequalities. So for me, the easiest way to do this is first break it apart. So 7 is less than z plus 2. That's one inequality. And the other one is z plus 2 is less than or equal to 11. So I'll solve both of them, subtract 2 from both sides. And we get 5 is less than z. So z is greater than 5. We subtract 2 over here, and we get z is less than or equal to 9. So now I'm going to graph them. So we have 5 is less than z. So it's going to be an open circle. So that means z is greater than 5. So it's going to go this direction. Z is less than or equal to 9 means my circle is here, it's filled in, and it's going this direction. So my answer is between 5, not including 5, and 9, including 9. So my answer is 5 is less than z, which is less than or equal to 9. So I take them apart to solve them, graph them, and then put them back together for my solution. This one's an or statement, so we'll solve them separately. So this one I'm going to add 7 to both sides. And I get 4k is less than or equal to 8. I divide both sides by 4, and k is less than or equal to 2. Over here, I subtract 12 from both sides. I get negative 9k is greater than 18. Divide by negative 9. Did you hear me say divide by negative? Okay, that means that I'm going to flip the sign. K is less than negative 2. So I'm going to graph this. This is an OR statement. So this one is filled in, and it's less than 2. And this one is open and less than negative 2. So when I write this, do you see that this first inequality sort of takes over this one? So it's an OR statement. So my answer is just going to be k is less than or equal to 2. Because since it's an OR statement, it starts here and just goes all the way to negative infinity. So it would already incorporate this k is less than negative 2. So I don't need to be redundant and write it twice. All right, this is an AND statement. So first let's solve this half. So we add 2r to both sides. And that gets us 4r plus 8 is greater than 16. Subtract 8 from both sides. I get 4r is greater than 8. Divide both sides by 4. R is greater than 2. Over here, I'm going to subtract r from both sides. It's going to be 6r plus 21 is less than negative 9. I subtract negative 21 from both sides. Get 6r is less than negative 30. Divide both sides by 6. We get r is less than negative 5. So I divide both sides by 1/2. And I get n is less than 2. So now I have them apart. I'm going to put them back together. So 0, n less than 2. And that is my solution. Write a compound inequality for the graph. So x is in the middle. This is negative 2. This is 5. This one is a closed circle. This one is an open circle. This one has to be an OR statement because our answer is both of them and they don't overlap. So x is less than negative 2, or x is greater than or equal to 1. So what's the important word when graphing an intersection? It is and. And when graphing a union, OR.